In the second quadrant, when we go left and up, we will find that the x value had to move left and therefore is a negative number, while the y value is still moving north and is therefore a positive number. And what that means in the second quadrant is that the cosine, which is determined by the x-coordinate, will be a negative value. The sine, which is determined by the y-coordinate, will be a positive value. And the tangent, which is determined by y over x, will also be negative, because positive over negative is negative. For this quadrant, we will say that the sine function is the only one that will be positive. Anything else will be negative. In the third quadrant, we'll be going left and down. That means that any coordinate point or any point P on the unit circle that lands in the third quadrant will be a negative followed by a negative. Therefore, the cosine of any angle in the third quadrant will be a negative number. The sine of any angle in the third quadrant will be a negative number. And the tangent of any angle that happens to land in the third quadrant will be a negative over a negative or a positive. We will say for third quadrant that tangent is a positive function and everything else is negative. In quadrant 4, we will be moving to the right and down so that the x-coordinate is positive, but the y-coordinate is a negative. This means that the cosine in the fourth quadrant of any angle will be a positive number. The sine of any angle that lands in the fourth quadrant will be a negative number. And the tangent of any angle that lands in the fourth quadrant, which is a y over an x, or a sine over a cosine, is a negative over a positive or a negative. This means that in the fourth quadrant, the only function that will be positive will be the cosine function. Scrolling down to below the next section of notes, we will remember this as all students take calculus. And the reason that we need to remember that is because this is the signs in quadrant 1, in quadrant 2, quadrant 3, and quadrant 4 for any answer for those functions. So that I can say that if this is a third quadrant answer, I know that my answer will be a negative. Since this is a fourth quadrant angle, I know that my answer will be positive. Because this is a second quadrant answer, I know that my answer will be negative. Everything in the first quadrant is positive, so the next two are both positive. And in the second quadrant, as we just discovered in the problem above, tangent is always negative. What we're going to do next is we're going to work on trying to find the exact value of any trig function using only bow tie trig. We're going to tie together the idea that we know the sine of all of these trig functions, in addition to we know that all four of these triangles are congruent, and therefore we are working in a bow tie. The angles that I'll be dealing with will all be 30-degree angles, which means effectively that the first angle that I'm dealing with is a true 30-degree angle. The second angle of rotation that I'm dealing with is actually a supplement of 30 degrees, or a 150-degree angle. The third angle of rotation that I'm dealing with is 30 degrees beyond the x-axis, or 180 plus 30, which is a 210-degree angle. And the final angle that I'm dealing with is 30 degrees shy of a full circle, or 330 degrees. When I look at the trig functions for all four of these angles, and if I were to type them into my calculator, what I would find is that the sine of 30 has the same value as the sine of 150, and nearly the same value as the sine of 210 and the sine of 330. The only difference with the last two answers is that the last two answers were negative. And the reason that they were negative is because in the first quadrant, everything will have a positive answer. In the second quadrant, sine, which is what I was calculating, had a positive answer. In the third quadrant, only tangent has a positive answer, which means that the sine value will be negative. And in the fourth quadrant, only cosine will have a positive answer, which means that only the sine, or only the cosine, will be positive and the sine would be negative. Yet you'll notice, because the four angles and the four triangles were all congruent, the size of the answer was the same for all four angles. The reason for that is because the reference angle, or this interior angle in here, was the same for all four angles, and that angle is known as a reference angle. The reference angle is an acute angle,
Oh.
You gotta be quick. What?
Book? Yeah, a book.
Bookshop. Quickly, quickly.
Why?
Because I'm recording and I'm running out of time.
Where's the camera? I'm sorry. And for the record, I usually do my math homework. It's just this once.
Yeah. Did I not pause? And that acute angle lies in the bow tie. To find a reference angle, we merely need to use some basic rules. In the first quadrant, we'll use the angle that we are given. In the second quadrant, we'll use the supplement of the given angle. In the third quadrant, we'll subtract 180 from the given angle. And in the fourth quadrant, we'll do 360 minus the given angle. We're going to call the given angle theta. And in quadrant 2, we'll do 180 minus theta. In the second quadrant, we'll do theta minus 180. And in quadrant 4, we'll do 360 minus theta. This is how we'll find a reference angle. To find the reference angle again, all we need to do is choose the quadrant that the given angle lands in and follow the appropriate rule. I'll do a few, and you can do the rest. 110 is a second quadrant angle, so I'll use the supplement of 110. The supplement of 110 is 70, so my reference is a 70. 280 is a fourth quadrant angle, so I'll use the supplement of 280. I will do 360 minus 280, and 360 minus 280 is 80. Remember, all of your answers should be acute. If they're not, you did something wrong. Would you please take a moment and calculate the reference angles for E through H? These are the answers that you should have gotten for those. And now we're going to use those answers to find a renaming for each function. What we're doing in this next section is basically finding an equivalent way to state any trig function as a function of an acute angle. It is worth noting in this case that your answer will be a function, not a number. Watch for the word function in the directions. What I'll do is I will decide on the quadrant of the given angle, and the sign, using all students take calculus, to determine whether my answer should be positive or negative based on the quadrant that I chose and the trig function that I'm doing. The second thing that I'll do is I'll find the reference for the given angle, so that every function that I do will be stated as a sine, a trig function, and an acute angle. For example, in number 1, 120 is a second quadrant angle. In the second quadrant, the sign is guaranteed to be a positive number. So I'll write the positive sign, and now I'll find the reference for 120. In the second quadrant, I use the supplement of 120, and that means I should use 60. Moving on to example 2, cosine in the third quadrant is guaranteed to be a negative number. So I will write the negative cosine, and now I need a reference angle. In the third quadrant, my formula for finding a reference angle is subtract 180 from the given angle. 190 minus 180 is 10. That means that if I were to type into my calculator the cosine of 190, I would get the exact same answer as if I typed the negative cosine of 10.